Hello, this is Electroluke. Today I'm going to do a complete review of the handheld oscilloscope made by JYE. It is the DSO150. This oscilloscope is actually a kit. You have to build it yourself. Well, there was SMD parts pre-soldered on the board. We'll take a look at that later. And this video will be separated into few parts. In the first one, we will overlook main characteristics of this product, the price. Then we'll take a look how to use this one. Then we'll take a look at the good things about this oscilloscope, bad things, and in the end we're going to draw a conclusion and we'll see if it is any good. So stick on. You can go to any part of this video, just press on the screen and let's get started. So this oscilloscope costed me about $20, but its actual cost is about $30. Actually, at this moment, there's 27% off the deal for this oscilloscope, so it's a good time to pick it up. But we're gonna see if it is worth that money. So before getting into the main characteristics and the functionality, just keep in mind the price. I mean, it was just $20 for me. I mean, real oscilloscopes are in the range of hundreds of dollars and thousands of dollars. So this is more like a very beginner's tool, toy. It is actually a kit. I'll discuss that later. So of course it has only one channel. Its analog bandwidth is up to 200 kilohertz. The sensitivity is from 5 millivolts per division up to 20 volts per division. Sensitivity error is lower than 5%. Resolution is 12 bits. Input impedance 1 mega ohm. Maximum input voltage is 50 volts peak. There are 3 coupling modes which you can select on the top by using a slide switch. So there's AC, DC and ground. Very basic. The max real-time sampling rate is 1 megasample. At least that's what the information claims. Time base is from 10 microseconds per division up to 500 seconds per division, and record length is 1024. So what that means is it has a memory of holding these 12-bit resolution voltages in 1024 points. There are 3 trigger modes: auto, normal and single. Trigger types: rising and falling edge. And we have a 2.4-inch color TFT LCD with a 320 by 240 pixel resolution. Now let's take a closer look at the scope, at its build quality, and then see what's inside. On the front we have the screen, 4 tactile buttons for various functions, rotary encoder. On the bottom we have the power supply jack and a slide switch for power. One important thing is that this kit does not include a power supply, so you'll have to get your own. Pretty much any 9-volt power supply will do. Make sure that it is lower than 10 volts because it can damage the internal ICs, and make sure that you have a barrel jack on the other end. On the top we have a switch for selecting coupling mode. We can have AC, DC or ground. Also we have a test point for 1 kilohertz square wave with the selectable amplitude. It's done in software. And we have standard probe connector. On the sides we don't have anything, and on the back also just 4 screws. When the package arrived, it came into this very simple white box. Actually, before going further, there are 2 models. 15001K, which I have, and there is also the 2K. The difference is that on the 2K version, the analog board doesn't have the pre-soldered SMD parts. The 1K has both on the main digital board and the analog board pre-soldered SMD parts. So just look for the 1K version if there's an option. So inside we had both the digital and analog boards in this anti-static bag. Just some foam, the actual oscilloscope, we have a probe which ends with alligator clips, and looking at this you can see the quality of this product. It's not very good. This I'm sure it's not shielded or anything, but I mean $20. Also we have 4-page manual, the steps how to do the kit, and I can say that it was pretty straightforward, pretty easy to follow. I'm not gonna go through that. One tip when you're doing the kit, look at the pictures, how the parts are inserted from which side. I mean, this probably is the only harder things that you can mess up. So make sure you put your parts in from the right side before you solder them in. That's pretty much it. You just get the scope and the probe. No power supply. That's a bit sad. Okay. All of the parts came into a plastic bag, and you just have to solder the through-hole components. And this copper shielding was not included. I did it by myself because, I don't know, this kit actually was very fun to build, and to play with this oscilloscope is a lot of fun. So just by that, it is worth that $20. So I shielded all of the case just for fun. I don't think it's gonna do any good changes, because it's pretty low frequency oscilloscope, but I did it. And I just took a simple copper tape from eBay and did that, connected all the parts with the solder, and that's pretty much it. Oh, of course I connected the shielding with the lead to the analog board's ground. Well, it would be enough to shield only the analog board, but I covered all the case because in this case it's simpler. So these boards, this is the analog board, and they are separated and connected by this pin connector. So when you build your boards, it is as simple as just making these pins go together and pressing. Before you have to put the back cap and of course the front cap. It's all shown on the paperwork. And yeah, that's it. I mean, you put on the front cover. The front cover is also in 2 separate parts, but because of the copper tape, it's sticked in. I'm not gonna pull it out. Well, this kit was pretty simple, but the hardest part was to figure out how to put the rotary encoder, and you do it just like that. Make sure you put the encoder on this separate board on the right side. As I mentioned, the right side has white strokes around the pins, and yeah, you just prepare this board, and then with this pin connector you push this mini board through the main board and solder connections here, these 4. If you're also going to try to add the shielding, put some insulating tape over the parts where connectors, where the pins stick out, because this case actually gets very close to the digital board, and you don't want to short anything, because this copper tape of course is not insulated. So I just put tape where it needs to be, and that's it. Also, I had a problem with the encoder cap. It was actually not aligning with the insert, and as you can see, and it actually has to act like a button, and it wasn't pushing all the way. So what I did, I put a little ball of the same copper tape inside it, so it would raise the pin a little bit more, and now it can push easily. I have an idea to improve this oscilloscope by adding a battery inside, and so it wouldn't be attached to wires. This oscilloscope is very small. You can say it's pocket oscilloscope, so adding a battery would be really nice, and I think I'm gonna do that maybe in this video, maybe later. Okay, now it's the fun part. We're actually gonna boot it, and let's turn it on. It starts to boot up. Alright, we have something on our screen, and because this signal lead is not shielded or anything, we can see it acting as an antenna because of the electromagnetic interference in my room from other devices, and this signal is actually 50 Hz because I'm in Europe and our mains power is 240 volts with a 50 Hz frequency. And actually we can have some measurements of this wave. If we hold the OK button, here it is, and it actually says it's the frequency is 50 Hz. It's pretty much on point. This oscilloscope is very crude and simple. I mean, it just does the basic oscilloscope functions. So forget any math functions or anything. I mean, this oscilloscope just shows the varying voltage on the time scale. That's it. So this oscilloscope is very easy to use. I'll quickly go through how it is controlled. So it has basically 4 tactile inputs, an encoder input. So if we press the first button, which is the voltage division button, the 1 volt gets highlighted, and now we can control the division voltage. Now it's 1 volt, so per every square we have 1 volt. So we can see that the square wave has an amplitude of 3.3 or something volts. If this 1 volt, this option is highlighted, with the encoder we can change the division size. When I talked about main characteristics, it can go from 5 millivolts down to 20 volts per division. And if we press this voltage division button again after it's highlighted, this arrow gets blue. So that means that we can scroll through the voltage axis like that. And on the top you can see these 2 little arrows. So by pressing the encoder button we can turn it on and off. So if there's no arrows displayed, you can adjust it more precisely, and if you press the encoder again you can adjust it a lot faster. Basically I almost always use the fast adjust mode. If we press the second division button, this option gets highlighted, and now we can change the time division by scrolling the encoder, and we can go from 500 seconds down to basically 10 microseconds. There's one problem, that if you go from 500 seconds it freezes quite a bit. So on the lower scale division it's pretty fast. Third button is trigger. By pressing that you can change the if it needs to detect the falling or rising edge, and you can change it by going left or right with the adjust knob. If you press the trigger again, now it goes to this option. Here we can select the trigger option, which is auto, normal or single. So, and if you press again, this arrow gets highlighted, and now if we lower it down, here we can see that now it triggers because it's in the amplitude of the square wave. And now we can again change it to rising or falling edge. As you can see, it it shifts by 180 degrees. There's the fourth button, OK. If you press that, it holds the view, it just freezes it, and by using first two buttons, voltage and second, you can, by double tapping those, we can take a look at the frozen graph. And when you go to seconds division, we can see those 1024 points shown right here. So we can slide. So basically that's the memory of this oscilloscope. And one bad thing is that when you freeze the graph, pretty obviously you can't change the division. And basically what divisions were set before pressing hold, they are shown and you cannot adjust them after that. So that's a downside. So this oscilloscope, you can analyze frequencies up to 20 kilohertz. So in the audible range, you can go a little bit higher than that, but the graph gets worse and worse. Basically, the more you go, the less you can trust what you see. There's a few additional functions. If you hold the adjust knob, this option comes up, and that's the test point amplitude selection. If you press it, it goes from 3.3 volts to 0.1 volt, and these are two options with which you can play. And now it's 1 volt, and if you hold it again, it disappears. One very important function is when you hold the OK button for some time, you can see some of the measurements, which are really nice. So that's actually the most of what this oscilloscope can do. So there's one drawback. Not on every division the frequency is right. If you see, I lowered the division up to 2 volts, down to 2 volts. The frequency is right, and if I get back to 1 volt, now you see it's still on 1.112 kilohertz. So that's wrong, because we know that this test point has to be exactly 1 kilohertz. And the same as with the time scale. So the more periods you can fit in the screen, the more correct the frequency is. At least that's what I found out. So yeah, if you want to check your frequency correct, just lower the time division. And also it's not right. With the voltages I get, now you can see it is 3.44 volts, but it actually is 3.3, because I tested it with my multimeter. I added a capacitor to smooth the signal out, and it is a very much off the true 3.3 volts. I played with this oscilloscope for quite a bit, and found out that you cannot rely on the measurements because they're very off. But of course it's better than nothing. And I just use them for a quick look. If you want to reset the device, if it's acting strangely, you press the second and trigger simultaneously for a bit, and now it's reset. On the paperwork I saw that if you freeze the square wave, you can save it to EEPROM by pressing the OK and trigger. I tried everything, but I can't get it saved, and if you want to recall it, you press OK and sec division. So I don't know, whatever. If you hold the OK again, these measurements go away like that. And if you want, if these voltage measurements are very off, you can reset them if you choose the coupling mode to ground. So it basically takes the signal to the ground point, and hold the V div just like that, and it's it resets the position. Also, it's the same with the second division. If you hold it, it resets something with its position. Oh, it resets the position on the viewfinder, because if you can scroll through it, you can see this cyan bar. I can scroll through the view, and if I hold the second division, it brings it to the middle. Also, if you hold the trigger button, it puts the trigger to the middle of the wave or something. So it's quite useful. It's a lot easier than adjusting it. That's pretty much it. So what are the conclusions? Well, this oscilloscope is very far from a quality bench oscilloscope. So the good part of it is that it's very cheap. It was a really fun kit. I mean, I don't do a lot of kits, but this was a lot of fun. And just for that, it's worth the money. It does the basic oscilloscope function. Even with this oscilloscope, you open a lot of doors to new projects. I would suggest this oscilloscope for beginner electronics hobbyists. It's really small. That's a good side of it. Currently, I don't have any other oscilloscope in my home. I've used the oscilloscope only in my university, but I'm looking for buying a real one, at least for a old analog oscilloscope. So yeah, I think I like it. It's more like a toy, not an oscilloscope, but it's fun, and that's what electronics is all about. So yeah, I think that's it for this video. Thank you for watching. If you enjoyed, consider subscribing. I'm just starting a new channel, and I have a lot in mind of new projects, even for this oscilloscope. I think on the next video, I'm gonna show how to upgrade it and put a battery inside it so it can be off wires. So that's cool. I'll show how to do that. Bye.